In this question, we are supposed to find the expected value of Poisson, which varies throughout time. So to get the expected value, it's very similar to what we did before. So we know that it's the sum from k equals 0 to infinity times e to the negative lambda multiplied by lambda to the k power over k factorial, and the sum of all that has to be equal to 1. So if we move the e to the negative lambda over to the one side, it becomes e to the positive lambda. And if we then take the derivative with respect to the lambda of that entire thing, we get e to the lambda is equal to this, and then we do, you see the k drop down to the multiplier and u minus a k. Now, in order to get that k minus 1 back to a k, you times everything by lambda, so you have lambda e to the lambda is equivalent to the sum from k equals 0 to infinity of k times lambda to the k over k factorial. Now after that, we move the e to the lambda back over, and we see that's the expected value of x. So the variance is the expected value of x minus the mean, the square of that, is also equal to the expected value of x squared minus the mean squared. So we determine the mean up here, and that means that it's the expected value of x squared minus lambda squared. So now we need to figure out what expected value of x squared is, and similarly, since we did this previously in prior chapters, we take the derivative of with respect to lambda of lambda e to the lambda, and we get this. And then after that, we can look at this, and again, we're going to get rid of the k minus 1 by timesing everything by lambda, and what we are left with is this 1 plus lambda times lambda. So you get the variance, and we see that it actually results in lambda being the variance as well. So to get the t back in there, we basically just multiply it by t due to the multiplicative property, since it's independent, and we get the expected value of x to the t is lambda t, and the variance is lambda t as well. So to find the autocorrelation of the Poisson process, so for T2 is greater for T1, we look at this and we see that, well, the very first thing is we can define our autocorrelation. It's the expected value of a function given a T1 multiplied that same function with variable T2. And so that's equivalent to the expected value of T1, and you could read from here. So after doing some plug and chug here, we get lambda T1 times the lambda T2 minus lambda T1 plus 1 plus lambda T1, lambda T1. And after working it through here, we get to see it comes to this. So we do the same exact thing, except for with T1 greater than T2, and we'll see that it comes out to be this. So we can see that basically whatever the minimum is, that's going to be the first, that's going to be this right here. So whichever one's minimum, it's going to pop out with that. So then we can write the autocorrelation as this.